Greetings everyone. Today we will continue our discussion for today about colligative properties of a solution. Colligative properties as a review is a property of a solution which focus more on the amount of solute rather than the internal properties of a certain substance. So, yun po, yung pinakasimpleng explanation lang about the colligative properties. So, under this, we have terminologies such as strong and weak electrolytes. So, we have also non-electrolytes, and we have a sort of review about a molality, and under colligative property of a solution, we have a vapor pressure lowering, boiling point elevation, freezing point depression, and osmotic pressure. So last time, we already discussed about the vapor pressure lowering. So for today, let's continue discussing about the boiling point elevation. So boiling point again is the point of a temperature at which the vapor pressure of a liquid is equal to the atmospheric pressure. If we change the external pressure from 1 atm lower or higher, the boiling point change as well. So tatandaan to mag-change din daw yung atmospheric pressure natin once we change the standard pressure. So this standard atmospheric pressure is the reference point is based on above the sea level. The main reason again is that 1 atm is the reference reference point. It is just because it is the edge or the boundary that separates between the liquid into solid. That's why 1 atm. So what happened now once we change that 1 atm into greater value? Ibig sabihin, sinasabi lang dito that if we change the standard, obviously, we will change the entire boiling point of a certain substance. Okay, a liquid with higher vapor pressure means that the molecule evaporate faster and it takes shorter time to equalize the vapor pressure of a liquid and the atmospheric pressure. So, as we can see in our illustration, we have a comparison between the atmospheric pressure of a pure solvent, so typical na tubig lang, and the atmospheric pressure of a given solution with lower vapor pressure. So obviously, it is connected to our first colligative property, which is under a lower vapor pressure. So again, nagkakaroon tayo ng lower vapor pressure because of the influence of the amount of a solute in a given solvent to form a solution. So sabi nga natin that once we add more amount of solute in a solution, the lesser the vapor pressure, specifically in a closed system. So yun lang po, yung connected pa rin dito. Okay, remember that addition of non-volatile liquid to a pure solvent causes the vapor pressure of a solution to decrease. Ito nga po kaninang sabi natin. So, as we can see in atmospheric pressure, in a second solution, a second picture in a glass, so meron tayong ditong solute. Ayan, itong kulay pink na to. So, this one is unspecified whether what kind of solute is this, but ang na-highlight lang dito that once we add a solute in a given solution, so the vapor pressure can be influenced. Ibig sabihin, connected pa rin sila together. Solution has a lower vapor pressure that is pure solvent. Yes, tama po yan. So, check yan kanina sabi natin. To make the vapor pressure of a solution equal to atmospheric pressure, we have to increase the temperature of the solution. Therefore, it takes higher temperature to attain the boiling point of solution that of its solvent. So, balik tayo dito. For this case class, sa topic natin kanina, sabi nga natin, in a second picture, in a second glass, in a aqueous solution, once we add up a solute in a given solution, ang nangyari is bumababa. bumababa yung tawag dito, vapor pressure. But in this case, in order to change the state of the matter from a liquid into gas, all we need to do is to add or increase the boiling point of the given substance. So, ibig sabihin, there are changes. Kailangan natin magbago ng boiling point sa case na to. So, sir, bakit po mababago yung boiling point ng mismo substance? Since nga na nag-mix tayo from a solute, so the tendency is that lalong nagiging strength, lalong tumataas yung mga intermolecular force. So, since nga na sumama na ulit dito, or nagsama-sama na yung mga intermolecular force, the tendency is that we need to increase heat itself. So, once we increase the heat, so target kasi natin is to break the bond between that solution. So, since nga madami na sila, so we need more heat to break that. So, that results to have a boiling point. So, connected pa rin siya with the concept of atmospheric pressure at the same time with the heat application. So, yan lang po siya. Kailangan natin ng more heat in order to attain a high boiling point than of its solvent. So, yun po. Kasi nga, dumami na, pag pure solvent, sa example natin tubig, pag we add heat, typically, that is the standard boiling point pa rin. So, 100 degrees Celsius. But once we add any substance or any solute in a solution, the tendency is that the intermolecular forces will mix that. So tendency is we need to add heat in order to break that joint force. So that results to high boiling point of a given solution. So yun lang po. Next, the difference in boiling point of a solution and boiling point of pure solvent is termed with elevation in boiling point. O, tatandaan yung keyword ha. The difference between the boiling of a solution and the boiling point of pure solvent is termed as elevation boiling point. So, ibig sabihin, later, we need to compare the boiling point of a two substance. Kung baga, ikukumpara natin sa mismong pure solvent or mismong tubig lang and into a solution na may halo na later. Kasi nga, magkakaiba na yung tawag dito, boiling point mismo. Di ba nasabi ko sa inyo before that it is possible for us to change the boiling point of a certain substance by adding solute or more solute in a solvent. So, typical sa tubig. So, from original na 100 degrees Celsius, pwede siyang maging 105 and so on and so forth. Depende kung gaano karami yung solute na ilalagay natin sa mismong solution. This is the amount by which the boiling point temperature of a solvent is raised or elevated. So, yun nga po, mamaya, sabihin natin, we need to add the boiling point of a given substance. The boiling point of a pure solution, so, ito na siya yung a solution, which ibig sabihin, a combination of solute will be minus it into the boiling point of a pure substance. We expect kasi that the boiling point of the solution is always higher kasi nga may combination na siya with solute as compared with a pure solvent. So, ibig sabihin yung formula natin dito, yung boiling point ng tawag dito, ng solution natin, ipagmaminus lang natin sa boiling point ni solvent. Okay po? So, yun lang. The increase in boiling point observed when a non-volatile solution is dissolved in a solvent is directly proportional to a molar concentration of solute particles. So, here is the formula. Sinilay po dito sa problem the term na non-volatile. So, ibig sabihin, in this case class, that mas lalong tumataas yung boiling point ng mismong substance when solute that we added is non-volatile. So again, pag sinabi po natin non-volatile, it is a substance that is not easily to evaporate. So, ibig sabihin, since nga matagal siya mag-evaporate, which means that the intermolecular force found with it is strong enough. So, ibig sabihin, pag strong, it takes more heat to break that bond. That results to high boiling point. So, kaya hinighlight siya dito. So, ito po yung formula natin. the delta TB or the boiling point of elevation. So, ito na po siya, yung boiling point ng solution natin. We have the KB or the molal boiling point constant. So, sa case natin na to, we will use already the molal boiling point constant. So, since constant nga siya, this one is always given. And we have the molal concentration of solute particle. So, this one is written with small letter m kasi nga this one is a derived unit. So, this one is most of the time is not given. Hindi siya given. So, kailangan natin i-analyze mabuti kung saan si solute. So, ibig sabihin, pag hindi siya, yung unit niya is not in molal, so all we need to do is to convert it into molal in order to, before we will utilize this formula. And we have the term I, so which stands for a Van Hoff factor for ionic solute. Sir, ano naman po yung Van Hoff factor? So, normally, this Van Hoff factor is in value wherein, kumbaga, ilang ion or it could be ilang molecule yung present na mamimix natin sa mismong solution. Kasi nga, nagmamatter siya kung gaano kadami yung ion na ihahalo natin sa mismong solution. So, later, example, sodium chloride. As in sodium chloride, we do have only two presence of ion. We have the sodium and chlorine ion or chlorine ion. Basically, two Van Hoff factors. So, boiling point of elevation, here's the formula kanina, is equal to boiling point of a solvent. So, most of the time, boiling point of a solvent is given and minus by boiling point of a solution. So, let's try this problem and how to solve. So again, we will utilize the formula in order to identify the boiling point of the boiling point elevation of a given problem. So, basahin natin mabuti. Sample problem. What is the boiling point of elevation of a salt water if the molality of a sodium chloride is 5 molal? So, given na siya yung unit natin. Nakikita natin. Naka-molality na siya, which is 5m. So, ibig sabihin, we don't need to convert that later. Note that the boiling point of water is 100 degrees Celsius. So, as you can see, the boiling point of the solvent is already given, which is the water. And the molal boiling point constant of water is 0.51 degrees Celsius. So, most of it is given na po. So, all we need to do is to substitute in our formula the boiling point elevation is equal to constant value, which is constant boiling point, which is 0.51. So, again, given siya lagi, lagi ito, the molar boiling point of water, so of substance 0.51, given na to ha, times 5. So, sa case natin sa problem ngayon, the molal of a solute is already in molal. So, all we need to do is to substitute na lang. Then, we have also 2. This 2 is originally tinatawag nating Van Hoff factor. So, again, in order to get the Van Hoff factor is we need to count the number of ions. So, example natin, in a given problem, sodium chloride. So, we have the sodium cation plus the chlorine anion. So, Na has 1 ion and chlorine has a 1 ion. So, ibig sabihin, isang cation or kung may mapakat-ion siya or ma-anion man, automatically tag-iisa yung bilang sa kanya. So, in this case, we will write 2. Okay ba? So, since this one is the given, all we need to do is to multiply this one. So, boiling point of elevation is equal to 0.51 times 5 times 2. And after that, we already identify the boiling point elevation, which is 5.51. So, ibig sabihin, from the standard boiling point of the water, which is 100 degrees Celsius, so mas tumaas yung boiling point niya because of the mixture, ay yung paghalo niya, paglagay natin ng sulyot na asin sa mismong solution. Hindi na siya 100 degrees Celsius. Ibig sabihin, ang gagawin lang natin is pag-i-add na natin siya sa standard unit of the solvent or standard temperature of the solvent, which is 100 degrees Celsius plus 5.51 degrees Celsius, which is, sabi natin, boiling point elevation na nakuha natin kanina, which is 105.3 degrees Celsius. So, ibig sabihin lang nito that there is 5.1 degrees Celsius increase in boiling point of salt solution. So, again, ang target lang natin is to identify the change or yung mismong dagdag ng magiging dagdag na boiling point sa mismong original boiling point ng solute pag hinaluan natin ng any substance. Ibig sabihin that pag dinamihan pa natin yung paglagay ng asin sa mismong substance, there are tendencies na makakaabot ng mas mataas na boiling point elevation. So, ibig sabihin, mas tataas yung boiling point ng mismong substance. So, example, in a real-life application, we add salt to boiling point when processing spaghetti in order to add a flavor to the food. So, totoo naman nga po yan. However, some people believe that addition of salt increase the boiling point of a water. Technically, they are right. Yes, tama po yan. Correct naman. Kasi nga, based on our problem given. But the increase rather than small, you would need to over 100 grams of sodium chloride of liter of water to increase the boiling point of a couple degrees, which is not healthy at that makes the food very salty. So, basically, tama yung explanation that once we add a salt, tumataas yung boiling point. Mas maluluto o mas mabilis na maluto yung pasta. But yun nga, based on the explanation is that, yes, pag dinamihan natin, lalong tataas yung boiling point. Pero maapektuhan na mismo yung magiging taste, yung lasa ng pasta, which is not healthy in our body. Extent, which a vapor pressure of a solvent is lowered and boiling point is elevated, depends on the total number of solute particle present in a given amount of solvent, not on the mass of size or the chemical identities of the particle. Okay, so we're done already with the boiling point elevation. So let's proceed with the freezing point depression. So normally, since nga nag-focus tayo kay water, the freezing point of a water is 0 degrees Celsius. So, in this case, from the word itself, depression, ibig sabihin, maapektuhan na yung 0 degrees Celsius ng water once we add a solute in a given solution. So, there are tendencies that probably na magiging negative na yung freezing point ng substance once we add more solute. So, in this case, the normal freezing point of a liquid in the temperature at which liquid becomes a solid at 1 atm. So, ito na yung standard natin lagi na pressure. So, it is a temperature which solid and liquid phase coexist under vapor pressure at the same. In order for a freeze water, the temperature is lowered. So, totoo nga naman. So, in order to freeze, pag nalagay natin yung tubig, ilalagay muna natin siya. Kailangan natin yung pababaan, yung temperature. And its particle become more ordered towards a solid phase in an intermolecular force become particle and permanent. So, normally, since discuss nga natin siya last time is almost similar lang, pag yung tubig, ang nangyayari sa particle ng water, since nga may kinetic energy siya, turning into solid, so the tendency is kailangan mag-release natin ng heat sa surroundings to, in order to for the particles to settle down and form or to shape a hexagon network. So, almost similar with the shape of the solid. Why is freezing point lowered when we add solute to a solution? So, ito yung tanong natin kanina. So, why daw na bumababa yung freezing point ng mismong solution pag when we add a solute? If a non-volatile, so again, non-volatile siya. So, hindi basta-basta nag-evaporate. A solute is added to a solvent, the ordering process is disrupted. So, ibig sabihin, hindi naapektuhan ng buong-buo mismo yung solution. As a result, more energy must be removed from the solution. The freezing point of a solution is lowered than the pure solvent. The magnitude of a freezing point depression is directly proportional to molality to a solution. O, tatandaan to. The magnitude of freezing point depression is directly proportional to molality of a solution. So this one is expressed with this formula. So ito lang po yung formula na gagamitin natin. We're in a delta TF, which stands for a freezing point depression. So ito yung decrease na kukunin natin. So almost similar kanina with the boiling point elevation. So titignan natin kung ilan yung nabago from the given standard na freezing point ng mismong substance, specifically water most of the time. We have also the KF, or that's almost similar kanina, which is the molar freezing point of constant instead of KB. So pinalitan lang natin KF. So again, most of it is given na po. So kumbaga, isa-substitute na lang natin sa problem. Then we have M. So M, or a molal, the molar concentration of solute particles. So almost similar formula, but later we will check it whether if it is in molal na. But pag hindi po, so again, all we need to do is to convert first it into molal. And we have also the I, or the Van Hoff's factor for ionic solute. So kanina, yun nga, sabi ko sa inyo that the Van Hoff's factor is yun mismong value kung ilang presence of ion, or it could be ion yung makikita natin sa mismong solution. Okay? So, let's try this sample problem. So, what is the freezing point depression when a 62.2 grams of toluenes is dissolved in 4.81 grams of naphthalene? So, in this case, class, so, hindi water yung nagiging solvent natin. So, ibig sabihin, we don't know exactly what is the freezing point of naphthalene. So, ibig sabihin, kailangan natin basahin mabuti pag hindi siya given. Kailangan natin talaga siyang itanong. A freezing point of a constant naphthalene is 7 degrees Celsius per molal, and the freezing point of naphthalene is 80.3 degrees Celsius. So, ibig sabihin, from the given problem, naphthalene, ayan po, naphthalene is our solvent. Opo, naphthalene our solvent. Ibig sabihin, toluenes or tolen is our solute. So, but, as you can see, the unit of our solute is in grams, class, kung napapansin mo. Pero, based on our formula, ang kailangan natin is the molar concentration of a given solute. So, ibig sabihin, ang gagawin natin is to convert the molal, convert the grams of toluenes into its molal. So, the given is in grams, so we're in yung formula natin, or the unit of the molal is in mole over kilogram. So, all we need to do is to substitute 62.2 grams of toluenes times 1 mole of a toluen over 92.14 of a toluen. So, ang ginawa natin dito is gagamitan natin ng molar mass. So, kung napapansin natin, grams nga siya. Target natin, i-convert muna siya into mole. So, ibig sabihin, grams, so gagamitan natin siya ng molar mass in order to convert it into mole. So, ito na agad siya, which is 0.0673 mole of toluen. So, goods na tayo dito. Get the molal. Mole pa lang kasi siya eh. So, all we need to do is to convert the, but as you can see, that the unit of our solvent is in grams. So, syempre, ang una muna natin gagawin is to convert these grams into kilogram. So, we can use the typical way of conversion. Pwede natin siyang gamitan ng movement of a decimal point lang. So, 1, 2, 3. So, 4 left kasi nga mas malaki si kilograms rather. 1, 2, 3, and after that, we can get the test. So, ibig sabihin, 0.675 mole of toluen over by 0.48 kilograms of a naphthalene. So, ito kasi yung base lang sa formula natin. So, after that, we will get the molal of a solute, which is 1.40 m. So, okay na tayo? So, once we already done with that, finished with that, all we need to do is to substitute to the formula. So, analyze natin mabuti. Yung 7 degrees Celsius per molal is 7. So, ito lang siya, given na, ni naphthalene. Constant nga lagi. Then, the molal, ito yung kinumpute natin kanina, of a solute, which is 1.40 molal. Then, multiply by its Van Hoff factor, so which is 1. So, sa case natin, 1 lang yung, tawag dito, yung magiging Kirchhoff Van Hoff factor natin. It is just because toluene is not an ionic compound. Instead, it's a covalent compound. Kasi nga, carbon, hydrogen, so basically, they are unexpected to create a conductivity sa mismong solution. So, that's why yung bilang lang natin dito is 1. 1 lang po pag ganyan. Kung kahit anong mangyari, 1 siya pag covalent molecule lang siya. Okay po? Typical way lang natin na pag-multiply is we have 7 degrees Celsius per molal times 1.40 molal times 1. And after that, we can get already the freezing point, the depression of a naphthalene, so which is 9.82 degrees Celsius. So, ito na siya. So, ibig sabihin, ang gagawin natin is i-minus lang natin siya into the original freezing point of the naphthalene, which is from the given problem is 80.3 degrees Celsius minus 9.82. So, after that, we can get a 70.5 degrees Celsius. Ibig sabihin, bumaba yung naging freezing point ng mismong naphthalene because of the addition of toluene sa mismong solution natin. So, yun lang po. Gets po ba? So, kung naintindihan, can I get a like? Ayan. Thank you. So, that's the degrees. The decrease is 9.81 freezing point of the naphthalene once the toluene is added to a solution. Okay. So, the Kf of a water, or the constant freezing point of the water, is 1.86 degrees Celsius per molal. Thus, the freezing temperature of 1 molal aqueous solution of any non-volatile molecule solute is negative 1.86 degrees Celsius or 0. degrees minus 1.86 meters. So, in this case, class, we will, this case is ginamit natin yung freezing point ng mismong tubig. So, which is often around negative degrees, negative 1 degrees na mismo. So, yung 0 degrees kasi nga, ito yung typical na freezing point ng tubig. Pero, yun nga, so, in a given and volatile solute, so, example natin dito, pag hinaluan natin yung tubig, ang nangyari, we can get a more lower freezing point ng mismong tubig. So, ibig sabihin in this case, ima-minus lang natin siya. That ends with a negative result. So, the freezing point of water is reduced or depressed by 1.86 degrees. Every solvent has a unique molar freezing point depression constant as shown as below. So, yun nga po. So, bawat, tawag dito, solvent, so as you can see in our table, we have the acetic acid. So, those are the common expected na magiging solvent natin. We have the acetic acid, the camphor, yung typical na inaamoy natin. So, which means parang mas okay siya ngayon sa akin kasi hindi maganda yung lagay ng natin, lalamunan. Then we have the benzene. So, mostly ito nangyari sa mga activity natin. Then we have the phenol. So, phenol is an alcohol. So, it is a 5 presence of an alcohol than a water. So, ito lang siya. So, as you can see, pag tinignan natin, yung normal na freezing point nila na pure, as for the water, 0 talaga. So, for the phenol, 40.9. So, medyo mataas pa siya. Then, the benzene, 5.5. So, mole freezing point, depression constant. So, this one is always given, class. So, ang nangyari dito is, ito yung sinasubstitute natin. Lagi here, ito, dito sa Kirchhoff factor, this one is constant. Then, the normal boiling point, ayan, kinumbine lang dito sa problem. Kanina, yung concept, kasi nga, tawag dito, nagta-touch or nag-a-align yung concept nila. Then, the boiling point elevation constant. Or, obviously, this one is also constant in every solvent. So, ibig sabihin, given na din siya in a problem. Ito, lahat to given. So, hindi na kayo problema. Nagsasolve na kayo. Okay? So, sige, next tayo. An effect of electrolytes as a solute to our freezing point of a solution is greater compared to a non-electrolyte. So, because electrolytes gives more mole of solute particle with ionized water. The greater the number of mole of solute, the more the reduced boiling point of a solution from a freezing point of its pure solvent. Yes po. So, yun nga kanina, kung titignan natin or analyze natin sa problem that the amount of a solute, so ibig sabihin lang nito, pag mas madami yung solute na ilalagay natin, is mas lalong maapektuhan yung mismong freezing point ng mismong substance. Kung analyze natin yung formula, maapektuhan din yung Kirchhoff factor. Kasi nga, pag example natin, ion yung nilagay natin. So, example natin asin. So, as compared with this problem, 1, so 2, mag-multiply tayo. Maapektuhan siya lalo. Ibig sabihin, mas bababa or mas tataas yung freezing point. Lalong bababa yung magiging freezing point. Dagdag na freezing point ng mismong solution. Okay po? So, this one is the last topic about colligatives. This one is all about osmotic pressure. So, nung last natin na topic, I already taught this one by means of descriptive way lang. Right now, we will use it by means of computation. So, as a review, we have the term osmosis. So, again, osmosis is a process of movement of a solvent in a given different amount of concentration. So, two areas po yung tingnan natin dito. Imagine, you have 100 ml of water, add by 15 grams of a table sugar to a water. On the other hand, you have a second cup with same amount of water. However, you added 45 grams of table sugar to a water. Just like the first cup, the sugar is solute and the water is the solvent. But you have to mixture with the solute and concentration. In comparison, we have two solution of an equal solute concentration. So, dito class sa case natin, kung natatandaan yung example ko, is a cell wherein, sabi nga natin from the process of osmotic or osmosis, water yung gumagalaw. Pero, that water cannot move itself pag wala siyang pressure na ini-exert. So, ibig sabihin, the water itself has its pressure to move from one area to another. So, that's why we have these three types. We have the hypertonic, hypotonic, and isotonic. So, for hypertonic solution, ibig sabihin, ang movement ito pag hypertonic solution is from less concentrated solution into more concentrated solution. So, yun lang po. Example natin nga sa cell. So, ibig sabihin nito that in an hypertonic solution, there are tendency that yung tubig sa labas ng cell is less yung concentration Kasi nga, yung target lang natin lagi dito is that yung movement is from less concentrated area into more concentrated area. General na yan. The movement is from more concentrated, from less concentrated into more concentrated solution. So, general na siya. So, for hypertonic, so baliktad siya. The solution with a lower solute concentration. So, the solution will have a lower solute concentration. And last, we have the isotonic, we have the equal solute concentration. Ibig sabihin nito that the two areas is equal with concentration. So, the tendency is that the movement of solute is mabagal lang. Okay. So again, we have the term osmosis or the movement of a solvent molecule through a semi-permeable membrane. So normally, for sure na pag-aralan natin to sa biology. So the movement of a solute from a cell inside and outside. So for the use of our cell membrane, which is described as semi-permeable. Pag sinabi natin semi-permeable, it allows only selective amount. Hindi lahat pwedeng mag-pass through. Yun nga po, sabi ko kanina, that yung target, lower concentrated, papunta sa mas concentrated. Malabnaw, papunta sa mas colored na mismong concentration kasi nga mas madaming solute. Next, a semi-permeable membrane allows the passage of a solvent molecule but not the solute molecule. The movement of a solvent molecule continues until the concentration of both sides is the same, with an increase in the volume of a solution or more concentrated solution. So, kung baga, yung movement na ini-exert ng water is continuously once na hindi pa naging equal yung amount ni solute in both areas. So, kung baga, ganun siya. Continuously mag-exert ng pressure yung tubig as long as na hindi na naging equal yung amount ni solute in two areas. Okay po? So, sige. As you can see, in a two picture, so for a solution and the pure solvents are initially separated by osmotic membrane. So as you can see, pure solvent siya or pure na tubig. Sa kabila naman is a pure solution. But in the second picture, a second part, a net transfer of solvent molecule to the solution occurs until its osmotic pressure yields equal rate of transfer in both direction. So, kung napapansin natin, dito, lalong dumami yung amount ng concentration kasi nga, ang gagawin nga ulit ng solute ang solvent natin is to add more solvent as long as na magiging equal lang yung buong solution. Yung target So, ganun lang po siya. So, okay. The apparatus illustrated in the figure show that a simple pure solvent and solution that are separated membrane only a molecule may permit. A solvent molecule will diffuse across the membrane of both directions. Since the concentration of solvent is greater than a pure solvent than a solution, the molecule will diffuse from movement side of the membrane to solution side faster than the rate of will in reverse direction. The result net transfer of solvent molecule from a pure solvent solution. So, yun nga po yung sabi ko kanina. From a pure, in this case, equal. So, sa kabila natin, sa solution kasi is concentrated. Sa kabila naman is diluted or less in solute. So, ang tendency dito is that ang gagawin ng tubig is we will exert a pressure sa kabilang side, sa mismong solution. And after that, tataas yung amount ng mismong solution because kasi yung target niya lagi is magiging equal sila ng amount. So that result, magiging equal sila ng concentration. That result, ang nangyari na mas dumami yung amount niya. So, kasi nga, para magiging equal lang sila lagi. So, osmosis can be prevented by applying pressure to a more concentrated solution equal to osmotic pressure in a less concentrated side. This can be accomplished either physically by applying force to a side of system or chemically by modifying solute or concentrated so that two solute and concentrated are equal. So kung napapansin natin, we have the term accomplished either physically by applying force side by system or chemically modifying. Normally class, kung wala tong semi-permeable membrane na naghihiwalay from the two, the tendency is continuously lang na papass through. But from this paragraph, we can say that we can stop the movement of the water. Ibig sabihin, all we need to do is to add pressure from a more concentrated areas. Kung baga, isa-stop na, lalagyan natin siya ng barrier so that the water cannot move. Or kung baga, para hindi mabawasan yung magiging concentrated niya. Pero, we can do that by means of na dadamihan natin yung solute or by means of applying a physical barrier. It could be harangan or any form na solid mismo. Kasi nga, continuously nag-exert ng pressure yung tubig eh. Kasi yung target niya lagi is maging equal sila ng concentration. So, ganun lang naman siya. If the external pressure applied to concentrated solution is greater than the osmotic pressure, the solvent molecules are forced to flow from concentrated solution side to pure solvent or diluted. The process is known as reverse osmosis as is fall in the purification of water. So, meron naman tayong tinatawag na reverse process or reverse osmosis. So, sabi dito is that the solvent molecules are forced to flow from concentrated solution side to pure solvent to a pure solvent. So, in this case, possible na mag-move yung mismong mag-move yung less concentrated na area. So, kagaya natin dito sa problem, itong less concentrated na area into a form of a solvent. Kumbaga, by means of forcing this, kumbaga, i-compress niya, dire-diretso. So, the tendency is that lalong mababawasan yung amount ng solvent niya dito, and possibly, yung maiiwan na lang is yung mga amount of solute. So, that is yung tinatawag nating reverse osmosis. That is more applicable in the process of purification of water. So let's proceed with the computation of the osmotic pressure. To solve for the osmotic pressure, here's our formula. So, we have this symbol, which is symbolized as osmotic pressure equal to MRTI. M stands for molarity of a solution. So, this time, we will use the molarity instead of molality. Pinag-uusapan natin right now is about so the movement. Then, we have R. So, R is a gas constant. So, as you can see, class, so normally, the unit is 0.08206 with the unit of liter times the ATM over mole times Kelvin. So, constant na yan lagi. Then, we have P. So, P stands for the temperature. So, all we need to do is, typically liter is given na siya. So, ibig sabihin, pag hindi siya naka-Kelvin, mamaya is kailangan natin siya i-convert sa Kelvin kasi nga, ang target natin is laging i-match siya sa constant. So, ibig sabihin, pag naka-Celsius, first step natin lagi, i-convert muna siya into Kelvin. Kasi nga, because of our constant na unit. Then, we also use, again, the Van Hoff factor for ionic solute. So, again, pag ionic solute, bibilangan lang natin siya kung ilang ions yung makikita natin. So, let's try for this. A sample problem, what is the osmotic pressure of a solution contains of 5.5 grams of a glucose of a 0.0 molar solution of sodium chloride at 30 degrees Celsius. So, as you can see, class, we will use a glucose. So, ibig sabihin, glucose is a solute here. And the given, it's already given the molarity of a solution. So, ang gagawin natin na lang is isa-substitute sa mismong formula. And so, since everything is already given, all we need to do is to substitute na lang. So, ibig sabihin, M for the molarity. So, ilalagay na lang natin siya sa formula times from the constant formula, which is R, 0.0828 liter times ATM over mole of in a Kelvin. So, the unit na gagamitin natin here is Celsius. So, again nga, gagawin muna natin siyang Kelvin in order to match from the given unit para makancel natin siya. So, all we need to do is to convert it through adding 273.5. So, ibig sabihin 30 plus 273.15 is equal to 303.15 Kelvin. So, in this case, class, automatically, ang mangyayari dito, pag naka-Kelvin na siya, cancel si Kelvin dito, cancel dito si Kelvin. So, ibig sabihin, ang naiiwan na lang natin na unit dito is ATM, mole, and liter, and ATM. So, si mole, pwede natin siyang makancel along with liter because of the unit of molarity. Molarity, because the unit of molarity is a mole over liter. So, ibig sabihin, cancel na si mole and liter. Kung baga hindi lang nilagay dito, pero molarity, pag chinok natin siya into smaller unit, molarity is always equal to mole over liter. Ibig sabihin, cancel. So, ngayon iwan na lang dito is ATM. So, the answer would be, or the osmotic pressure will be 99.5 ATM. So, yun lang siya. So, ito pala yung hindi ko na-discuss kanina. Sabi ko nga, we have the 2 Kirchhoff law kasi nga sodium chloride yung hinalo natin. So, we have a 2 ion lang kanina. So, ganun lang siya. Basic substitution. Okay po? Naiintindihan? So, here is the formulas na kailangan nyo lang po. So, yan lang po yung magiging cover natin for the last topic. So, basically, again, as a review, sabi ko nga sa inyo, konti lang yung item na kukunin natin dito. So, good luck and wait na lang po tayo sa reviewer. So, thank you and goodbye po.